Hello. Hello everyone, my name is Joecks and I'm working at HERE Technologies. And today I'm going to talk a little bit about how to survive the life cycle, and this is mainly around the architecture components and how we actually deal with the certain kind of life cycles that they are now introduced to us. And for this I'm going to do a little bit of a short introduction to this kind of let's say objects, you could say. So in general, everybody is more or less aware of the architecture components. Raise your hand if you have heard of it. I think everybody knows nowadays about this. I just give a very short recap, like 2-3 minutes, just to be really on the same page, because some of the things that I'm going to talk about later are going to have some recap, basically. So, first of all, the life cycle. The life cycle is basically just an object that was introduced to hold the state of an activity or a fragment, and basically represent, not hold, but represent the state of an activity or a fragment, and give you the opportunity to be notified about it. So this is sounds simple, but it is actually something that changed a lot in the architecture or in writing good applications, because now you can actually make some guarantees, and you can also subtract certain kind of aspects from your application that should never touch an activity or a fragment. Also, a very interesting part of this is that the life cycle is actually provided by a certain kind of guarantee. So the steps here, like on create, on start, they are always basically called in the same kind of order. And building on top of this is way better now, because previously in with different Android versions, you had some issues with this kind of ordering. As a second object that we, just to recap quickly, we have the Lifecycle Owner, and I'm going to talk a little bit about more Lifecycle Owners later. And it's basically just an object that holds a life cycle, and so you could build your own Lifecycle Owner if you need to, if you want to build your own UI framework. And last but not least, in this kind of the three important objects, is the Lifecycle Observer. And the Lifecycle Observer is helping us to actually realize when something happened, when something changed within the lifecycle. And here I took the Android X Lifecycle, a library, and there you have some new kind of observers, like for instance the full Lifecycle Observer, which is a really nice different implementation than using the annotations, which is a little bit less efficient. How many of you already started to use Android X? Nobody? Well, it's pretty fresh, right? So, on top of this, Google in the I/O 2017 introduced a very useful object that is called the live data object. And this is just basically an emitter observer pattern where you can hold an object, and it's going to react on your life cycle. And this sounds very simple, but it's actually changed a lot, at least in our architecture and how we build applications, because now you don't care about the life cycle anymore. You're basically just emitting data, you're producing it, and whenever anything happening to the life cycle, we just get informed correctly. Very important here to mention it, that it starts to emit data when it's fresh, when you come actually in the lifecycle on start, and it's going to automatically remove all the observers and on destroy. And we're going to come to this point in a second, because it's actually important to realize this. Last but not least is an concept that's the view model that is basically holding everything together across activities or fragments when they are destroyed. And this is the view model. A view model is nothing more than basically kind of a retained state where you can add a live data objects or any kind of other objects that are going to be held across basically the life cycle of your of an activity or fragment. So with this 5 simple classes, you can actually do really, really cool stuff. But how do you actually bring everything together? So first of all, from Android X on, we have those kind of life cycles built in, and also with the app component 26, I think, you get all of this life cycle objects basically built into the standard libraries, and there are 3 of them that you should realize. And I'm going to talk about the last one in a second, and the first 2 are basically the fragment lifecycle owner, the fragment activity lifecycle owner, and then the other one is the fragment lifecycle owner, and the new one that is introduced now with the Google I/O 2018 is the view lifecycle owner. And that's a particular one because it's a little bit different. It's not totally intuitive what it is doing and why is it there. Who of you heard actually of the view lifecycle owner? Okay, just a few hands raised, so this is good, because I think this talk is mainly about putting awareness on this new object. And this new... Okay, so how does it work? So this is just a general recap, and maybe you're realizing the style a little bit, because I copied it from the Google I/O slides, more or less. So on the top, you can actually see the a view model that holds some kind of data in a live data object, and it's going to emit something. And this something is going to eventually be drawn on a fragment. But the fragment first needs to go through some kind of cycle. And the cycle starts with onCreate, so this is just a normal call at the normal lifecycle method. At this point, we're going to actually register, because that's the nice thing about those kind of lifecycle methods. You can just do everything in one method, and in the onCreate method in this case. We start to observe, but at this point, we are not getting actually this kind of value delivered right away, but we kind of have to wait until we are notified to be on start. On start, at this point, it's actually safe to draw anything on the screen and changing basically the view. And then we actually get delivered this kind of object, and we can do something about it. Interesting is then if we are moving towards, like if we're rotating, for instance, a fragment, then we are actually gonna, of course, we get the onStop event, and we are marking our observer as inactive. At this point, we will not deliver any kind of further update anymore. So this means any object B that you can see here on the right is not actually going to be delivered, and it's also going to be marked internally as not delivered to this particular observer, which is an important aspect. So then the fragment is going to be destroyed, all the resources going to be removed, and then eventually also the observer is going to auto-remove itself. So no more boilerplate code to just go on destroy and unregister your observer. It's a very, very clean setup, basically. And in our applications, actually it helped us a lot to have a very, very simple way to describe what is happening in your application. So what is happening next? We have the rotation case, so once you rotate the fragment, a new fragment is going to be created. We go through the same stages. onCreate is going to be called. We start observing again, and then we're going to go through onStart, and on onStart, we got actually the value that was not delivered previously is now delivered freshly to us, and so from there on, we can actually draw the updated value. So you can realize that it's basically a very simple concept, but it actually helps a lot to build anything that is going asynchronous and anything that shouldn't be bound to the view. Who of you is actually aware of this kind of life cycle and understood it already previously? Okay, that's nice, perfectly. Then I hope you're going to have a little bit more input on or fun on the next part. So this helped us actually to do simple setups like this. So you had basically in onCreate, on the fragment, you could actually just get the view model, and then from the view model, you would basically just observe the with the fragments lifecycle, you would observe the changes on the view model, and then you get actually delivered this object B. Who of you knows actually that there's something wrong about this, or problematic? Just a few hands. So who of you is using this kind of construct? Okay, not too many actually, so I'm surprised. Okay, so what is problematic about this? So if we are not talking about the case of rotation, where a fragment is going to be destroyed, but we're talking of the case when we're actually moving from one fragment to another in a fragment manager. So like a backstack case. You're moving like from one fragment to another, and then you go back to your previous one. So a few of you might know that at this point we are actually keeping the fragment in the memory, but something else is happening. So first of all, let's go through the same cases. So we have the live data object that is going to emit the object A. We go through onStart, and we're going to draw this again on the fragment. Then we are actually moving to the other fragment. At this particular point, we are keeping the current fragment actually in the fragment manager. We just call on stop. Then we're going to detach the fragment from the view, and we're going to start the other fragment. The other fragment is started at this particular point, and it's going to do its magic, whatever we need to do that, and then we eventually press back. When we press back, the previous fragment is going to be reattached. And then it's going to its own cycle again. It's going to call on start, or on start is going to happen, and then we mark our fragment as active again. Who of you sees an issue with this? Because we have had the same observer as previously, we actually marked A as already delivered. But what happened in detach and attach again is that we actually destroyed the view. So there's a brand new view at this particular moment when we're reattaching the fragment. And this view doesn't know anything about A. So what you're going to show at this particular moment is an outdated view. So this is a problematic issue. So you can solve this issue with two kinds of ways. One way would be to actually tell the view to render this object A again. Just calling this cluttery setup, which is making your app very ugly, basically calling an onCreate, they change the view method that is basically going to be used again in onViewCreated, where we basically check if we have actually a value, and then we call it again to basically redraw it. At this point, you're basically safe. You are on the same page like the object A. Another setup many developers are using is actually this. And this is also what our application has used a couple of weeks ago until I actually fixed and removed the bug that is coming from this. And so we actually would, on view created, we would listen to the observer. And so we are fine because it's a new view. And then we get also a new observer. At this particular point, we would always be notified when any object was changed with this observer. But the problem with this is that we are still using the fragments lifecycle. The fragments lifecycle is not destroyed, so because we are keeping it in the memory, and so when we're coming back, we will call this method a second time, and of course, can you imagine what happens at this particular time? We will create a second observer, and suddenly we have two observers. And we also keep, we can keep a reference to the previous view, and by that leaking memory. So a way to actually solve this problem is to call an onDestroy remove the previous observer. This was a fix, but of course you can see it clutters your code a lot, especially if you have a lot of live data objects that you want to listen to. You're going to have a lot of this kind of boilerplate code. And of course, this is jeopardizing the whole idea, actually, on how to use live data and the lifecycle correctly. Okay, so in the Google I/O 2018, they realized, okay, we have to actually dedicate a certain kind of lifecycle for this, and this is the View Lifecycle Owner, or the View Lifecycle. This is a very particular lifecycle that is only available after onCreate view and until onDestroy view. And with this one, you're actually totally safe, because at this time, when you actually come back to the, when the view is going to be destroyed, this is going to be marked as destroyed, and the observer is going to be removed automatically. So you have, again, your beautiful setup. You don't have to do anything that is additional remove codes. And the architecture components are coming back to their promise to be very simple and help you with the application development. But now, you actually have two life cycles. And this is actually really confusing, because suddenly you have to decide, which one do I use? Do I use the fragment life cycle? Do I use the fragment view life cycle? Which one of those is actually the right one to use at which kind of moment? And so now we're going to step back a little bit and look at the architecture and try to figure out what would be a good practice actually to use which of these kind of life cycles at what time. So in general, we observed like a certain kind of pattern around applications and how they are abstracted, basically, in different kind of steps. And so one of the levels of abstractions is that we are using the navigation basically, which is the most top-level abstraction in any kind of application. In this kind of abstraction, we're going to do things like starting activities, starting fragments, dealing with the backstack, etc. So this is you can say, the higher level. Then in the second level of abstractions, we have use cases. They're going to deal with your individual business logic on a screen, basically. Things that you're doing there is composing views, showing errors, dialogues, dealing maybe with permissions. It's basically your core business logic implemented. And then there's a third level, which is basically a cross-cutting level for if you want to reuse certain kind of aspects of in your application. That is basically like showing data, manipulating data. You can think of this like, for instance, like a list view with a complicated filter mechanism that you want to reuse across all of your activity or application. So these are the three basic abstractions, and I'm going to now discuss how we can actually deal with this kind of three abstractions with the lifecycle. So there's the simple approach. In a simple approach, the activity is basically going to observe a view model. And the view model is taking care of both navigation and use case. So you can think of this as a very simple activity that deals with composing different kind of fragments on the screen to show everything related to the use case. And if you move to another use case, it's going to take care of composing these use cases again together. And so this is basically it would still work as in the other live data example. Whenever anything changes in the view model, it would basically move to the other state. So what is it doing? It actually shows fragments. And the fragments are here actually observing with the view lifecycle, not with the fragments lifecycle, but the view ones, and to just basically avoid all kind of pitfalls here. And we are observing then any kind of object that is dealing only with the view. So you have a very, let's say, simple construct. So if you're just building a simple application, I think this construct is good enough to basically hold most of the cases. So how does it look like in code? So you have the view model. So here I used the example where I have like something like a name list view model, like a list of names, and you have a state here. That's the view state. It's only the fragment example because I avoided the activity for the example's purpose. And then in the fragment we have we're gonna on view created, we're going to use the view lifecycle owner to basically observe only the changes of this particular list. And we are good to go. And that's going to be like, for a simple application, I guess the 90% case for you to basically manage both moving around from one fragment to the other, composing everything, and having kind of a safe ground here. But if you're moving a little bit further, and as we do in our application, actually we're growing bigger, you kind of have to do a one level higher abstraction. And here you actually start to think of the navigation as something that is completely independent of the use cases. You're basically just saying, okay, I'm navigating from A to B. I don't really care what is in B. I'm just going to basically tell the fragment to just be displayed, and I'm not actually dealing with what is inside the fragment, more or less. So this is a very nice way to actually build applications, because at this point you don't actually have to deal with any kind of business logic that is low level. And so what is a fragment then doing? Internally, it will basically still deal with the two life cycles. It's going to use a higher level of life cycle to deal with the use case specific things, and I'm going to come back to an example what this could be. And then with the all view-related stuff, it's going to still observe in the view model with the view lifecycle. So you would have basically two separated parts of within your fragment. How does this look in code? So first of all, as I promised, the use case could look like this. So like you enter the fragment and you have different kind of aspects of this particular business logic. Like you want to show a list, you want to maybe edit a name by long pressing on it or something like that. You have to deal with some kind of network error because you fetched the list from the network, or you are just in the loading state at this particular moment. So these are certain kind of things. They are not really view related in particular. we're just describing a high-level situation of this particular use case. And then you still have the, so you would represent this in a live model, a live data object that is the use case state. And then last but not least, you would have still the known view state that is basically representing the live data object of the state. And you would update all kinds of constructs here. You might need actually for each individual part of the view, you might need an own live data object here. So this sounds a little bit cluttery because you're actually putting a lot of code into your view model at this point. This kind of screams on putting this in a one level deeper actually. So I forgot actually to show the fragment, how this is implemented. So in the fragment, you actually, in onCreate, you will still use the fragments lifecycle to observe the use cases parts, and then you would show and hide basically views, more or less, or compose them, reinflate them, whatever is necessary actually for you to actually dealing with this particular problem. And then in onViewCreated, you would use the view lifecycle owner to still observe basically the view state of your view model. And then you're still basically safe to only deal with and update your view. Okay. So in our application that we are building, we are coming actually to this situation where we are finding ourselves more and more that this kind of approach that I just presented, which we are actually using in a similar way, is actually not scalable enough, because we might have to deduce, we have way more view aspects that have to be maybe moved to a different part, and they have to be reused because we are keeping the same patterns across the application again and again. And so, of course, it would be a pity to basically just rewrite this kind of views over and over again. So basically, we are moving more and more towards actually composition than using the extension case, where you would just basically take the view model and extend it to have a different kind of functionality. The good parts about composition is that you have really clean responsibilities and very clean documentation of what your component can do actually. So, and testability is actually really great. So how does this look like? In the composition case, again, high-level activity is taking care only of the navigation. Still the same. It's going to show fragment, and the fragment is only taking care of one thing. And that's, with its own life cycle, it only takes care and observes the use case information. And once you actually get any kind of information about how to change the use case, you're actually going to deliver it on the third level, actually, on the view container, or like a view level, you could say, where we're going to use the view lifecycle. So this is going to be then held internally, and there it's actually observing its own view model, and it's going to update basically aspects of itself accordingly by using the same. So how does this look in code? As an example. So in, again, we have the same kind of view model, but now it's split up, so I don't show this again here anymore. So the one part of the view model is actually in onCreate. We can switch around. Depending on the use case, we can switch around and change basically the view. Like for instance, we would change the visibility of the name list view. So this is just not a simple kind of view, it's a little bit of an extended custom view, you could say. In onViewCreated, we will actually not use the lifecycle, but pass it down to the view. And if you followed the Google I/O 2018, you actually have seen that, especially with data binding, this is it's going exactly into this kind of direction, where we are actually passing directly with the view lifecycle owner, passing directly the lifecycle to the data binding component that is dealing with binding directly to the view. But here now you have a more general pattern that you can actually use by building views that you can reuse across your application. And so we pass this down, and this is how a possible custom view could look like. With Kotlin, it's actually quite nice because it's just, the constructor is very, very thin. And in the attach method, we are doing exactly what we used to do actually in the fragment. We're just basically gonna get the view model, and then we're gonna observe it, but with the given lifecycle. And of course, this is helping a lot of testability because this is not related to any kind of activity or fragment code, and it's really plain and simple. A good other aspect of this is that you can now compose your views actually with higher level logic in XML, and you can give it attributes to actually instantiate a different kind of behavior that you can then pass to your view model, and you have basically a different kind of higher level view. And that's all.